All right, babies, we are starting 3.4. This is our last major section of Unit 3, and we're going to be talking about rational inequalities. So we've already done part of this because we already talked about rational expressions and equations and all of that. But now we're going to talk about rational inequalities. So now, if you will think about what it means to be an inequality, okay, you're probably familiar with all of these symbols. And inequality means now we're kind of shifting out of this idea of, hey, there's one solution or two solutions or however many solutions to our polynomials and that kind of thing, to now rational inequalities, remember, show us a group of things, or what's happening with my graph. Is it greater than or less than something, etc., etc. So when we're talking about inequalities, it's important that we find our critical numbers. What are our critical numbers? Well, it includes, our critical numbers includes all zeros and all restricted values that we can find in a specific expression. So what does this look like? Well, in order to find the critical numbers, okay, this is an important point here. To find critical numbers, you must have a single fraction. That means if a fraction, if you have an operation of two fractions, these two that are subtracted, I have to get a common denominator. That's why we talked about this when we looked at rational expressions. So I have to get a common denominator here. So the LCD, the lowest common denominator, is x times x plus 2, because it has to contain everything in both of the denominators. So if you'll recall what we talked about in this, okay, when we did these right here, these operations, okay, when we learned how to add and subtract fractions, we've got to get that common denominator. And now the goal is not to get rid of the fraction, it's just to combine the fractions so that we have one single fraction. So I am going to erase that so we can see what we're doing here. I've got to multiply this fraction by x over x, and I've got to multiply this fraction by x plus 2 over x plus 2, all right, because I need that denominator to look like that denominator. So that's why I'm doing that. So I've got x times 1, which is x, over my LCD, minus 1 times x plus 2 over my LCD. And now I'm going to write that as one fraction. So I've got this right here, got x minus 2, that has to distribute, and that leaves me with only negative 2 over x times x plus 2. So now we're ready to find our critical numbers. Our critical numbers, anywhere you have an x, that factor needs to be solved. So if you'll notice, there's no x in my numerator, so that just leaves my denominator. So I'm going to set x equal to 0 and x plus 2 equal to 0. So my critical numbers are 0 and negative 2. And I'm going to show you what we're going to do with them in just a minute. First, we need to practice. So let's look at this problem right here. This one, it's already in one fraction. So now I have to find all my critical numbers. Once it's in one fraction, that's my go-to. So you have to look at the numerator. It has a variable in it. So I have to set it equal to 0 and solve. Okay, and then I've got a factor here, x plus 5, x equals negative 5, 4x minus 3. Okay, so these are my critical numbers. They're critical because they're going to be important in helping me find the solution set for my inequalities. All right, so that's how we find critical numbers. So remember, we've got to have one fraction, a single fraction here, and then we can set everything with a variable equal to 0 and solve. All right, so let's mosey on down here to simplifying inequalities. All right, here we go. We will solve these using a sign chart and with the calculator, which we're not going to use the calculator, so get rid of that. All right, so the first thing you need to remember that with inequalities you have a set of answers, okay? You have a set of answers, not just one single thing. So you're not going to have something like x equals blah, blah, blah. You're not going to have that. You're going to have a group or a set of answers. So it's important you understand that. We're going to solve this just as we would any equation. I'm going to show you in the examples exactly what I'm talking about. We are going to list all of our critical numbers, went through some of that a little bit with you. Then we're going to graph our critical numbers on a number line. And we're going to use test values in our original problem from each interval in the number line. Again, this is going to make sense when I show it to you. The values that give you a true statement identify your answer. And we will write our answer using interval notation. What does that look like? That means in the form of using parentheses and brackets and unions if we have to. That's what interval notation is. That's what I'm talking about. Okay, so that's your intro into how we're going to talk about and deal with rational inequalities. Now we're just going to go ahead and jump into this first example here. So if you will look at this, the goal here, and it's very important that you understand this, the goal is to have a 0 on one side, all right? And we already do for this one, so it should be easy peasy lemon squeezy. There's not even any factoring that I have to do. So once I've got a single fraction, all right, which I do, I have a single fraction, and it's on one side, and 0 on the other, I'm ready to go here. These are already factored. I don't have to worry about that, so I'm ready for my critical numbers. So I set x plus 4 equal to 0 and solve. I set x minus 2 equal to 0 and solve. So my critical numbers are 4 and 2. Okay, those are about to become very important to us. We are going to create a number line now. One, two, three, four, 5. All right, we have to think about something. Notice that x minus 2 is in the denominator. That means we have a domain restriction. That means that x cannot be equal to 2 because that is going to make me divide by 0, and that's a no-no. So if I have a critical number at 2, but the inequality can't be 2, I'm going to have an open circle, just like that. All right, and if you'll notice, I forgot my negative here. This critical value is -4. Sorry about that. Man, that's why I can't have anything nice. Out of control. One, two, three, 4, 5. Okay, so there's -4. Sorry, kids. All right. So I'm going to have an open circle at 2 because I can't have a value in my set of answers that's a 2. And at -4, I don't have any restrictions. It's in the numerator, so I'm going to have a closed circle. Now, I want you to notice that this now divides my number line into 3 regions, okay? I've got region 1, region 2, and region 3. I am going to test a value in each of these regions. It does not matter what number you test. So my test points, in region 1, I'm just going to choose -5. So I'm going to test negative 5 in my original. So here's my equation, or my inequality. So I've got negative 5 plus 4 over negative 5 minus 2 greater than or equal to 0. So negative 5 plus 4 gives me negative 1. Negative 5 over negative 2 gives me negative 7. A negative divided by a negative is a positive. So is 1/7 greater than or equal to 0? Yes, it is. This is a true statement. Okay, so that is a true statement for that region. Now I'm going to test a number in region 2. Well, I'm going to pick the easy one, 0. So I'm going to have 0 plus 4 over 0 minus 2 greater than or equal to 0. So 4 divided by negative 2 is negative 2 greater than or equal to 0. This is not a true statement. Okay, so region 2 doesn't work. In region 3, grab a number. It doesn't matter which one you choose. I'm just going to grab 3. So 3 plus 4 over 3 minus 2, 7, definitely greater than 0. So we have a true statement for region 3. What does that mean? That means that this region is part of my solution and this region is part of my solution. So my notation, my interval notation is how I'm going to write this. In this direction we have negative infinity up to negative 4 with a bracket because negative 4 is included in my solution. And then I've got parentheses because 2 is not included, and all the way in this direction to positive infinity. That is your solution. That's how you find the solution for these. Okay, we will do the other 2 examples in another video.